Welcome to this explainer. Today, we're not just looking at chemistry as some dry, dusty textbook subject. Nope, we're treating it like the ultimate cosmic cooking show. Just imagine a kitchen where literally the entire universe, every star, every planet, every single cell in your body, even the screen you're looking at right now, is made from just a handful of base ingredients. It's absolutely mind-blowing when you realize that all the infinite, chaotic complexity around us actually boils down to a very specific, beautifully organized set of rules.
Here's our recipe for today's bake. First, matter's grand family tree. Second, elements, the raw ingredients. Third, meet the element families. Fourth, compounds, the cosmic bake. And finally, number 5, elements versus compounds.
Kicking things off with Section 1, matter's grand family tree.
So, before we actually start cooking, we've got to organize our pantry, right? Take a look at this flowchart of reality. Right there at the top is matter. Literally anything and everything that takes up space and has mass. From there, it immediately splits into 2 branches, pure substances over on the left and mixtures on the right. Now, mixtures, like the tap water in your sink or the air you're breathing, they don't have a strict, definite set of properties. They're basically just things jumbled together in any old proportion. But for today, we're focusing purely on that left side, the pure, fundamental building blocks of reality.
And that brings us to pure substances. By definition, a pure substance has a definite chemical composition, along with definite physical and chemical properties that are completely uniform throughout its bulk. But, what does that actually mean for you? Well, it means if you take a solid block of pure gold and somehow chop it up into 1,000,000 microscopic pieces, every single one of those pieces is still definitively gold, behaving in the exact same way. The same goes for pure water. There are no surprise ingredients hiding in there. It's entirely uniform and completely consistent, through and through.
Moving right along to Section 2, elements, the raw ingredients.
I mean, just think about the sheer staggering variety of stuff in the world. Trees, skyscrapers, vast oceans, your own DNA. You'd totally think the universe requires millions of unique, customized building blocks to create all of this, right? Well, no way. Out of all the mind-boggling complexity in the known universe, there are only 118 known elements. That is literally it. Just 118 individual types of atoms that make up absolutely everything you have ever seen, touched, or interacted with in your entire life.
And honestly, this brilliantly illustrates just how wildly resourceful nature is. Out of those 118 known elements, exactly 92 of them occur naturally right here in the Earth's crust. From the oxygen we're breathing right now to the iron pumping through our blood, Mother Nature is running the entire cosmic show with a pantry of just 92 natural ingredients. It's kind of incredible.
So what about the rest of them? Well, the remaining 26 elements are entirely artificially created by scientists in laboratories. Now, these are often highly unstable, radioactive elements that really don't stick around for very long at all. But they prove something amazing. We can actually add to the universe's pantry through our own scientific ingenuity. Now, while it's true that elements are made of only one kind of atom, they don't always like to be alone, which brings us to a concept called atomicity. Basically, atomicity is just the number of atoms present in a single molecule of an element. Some elements are perfectly happy flying solo. We call those monoatomic, but others, they like to buddy up. Oxygen, for instance, typically travels in pairs as a diatomic molecule. Other elements form triatomic or even massive polyatomic groups. It's the exact same fundamental element, just traveling around in different pack sizes.
Okay, let's dive into Section 3, meet the element families.
Let's get our pantry truly organized. Over on one side, we've got the metals. They're hard, shiny, malleable, sonorous, and absolutely fantastic conductors of heat and electricity. Then, over on the flip side, we have the nonmetals. These are your dull, brittle elements that are basically terrible conductors. But as we know, nature absolutely loves to break its own rules. Take mercury. It's a metal, sure, but it's totally liquid at room temperature. Or what about graphite? It's a nonmetal made entirely of carbon, but it conducts electricity brilliantly.
And then we have the weirdos and the snobs of the periodic table. The weirdos are the metalloids, like silicon and arsenic. These guys seriously can't make up their minds. They show properties of both metals and nonmetals, which actually makes them incredibly useful for things like computer chips. And then we have the noble gases. Helium, neon, argon, these are monoatomic gases that are chemically inert. Basically, they're the extreme introverts, or let's be real, the snobs of the elemental world. They outright refuse to chemically react with anything else. They just exist, totally unbothered by all the chemical chaos happening around them.
All right, time to heat things up. Section 4, compounds. The cosmic bake.
Now we're officially turning on the oven. A compound is a pure substance composed of two or more elements combined chemically in a definite proportion by mass. You've got to think of it like a strictly enforced, uncompromising baking recipe. If you don't follow the exact mass proportions, the whole recipe fails. And because these elements are actively chemically bonding together, the smallest possible unit of a compound is no longer just an atom. It is now a molecule. To truly appreciate just how wild compounds actually are, let's look at a specific recipe. Let me introduce you to ingredient 1, sodium. Now, sodium is a soft metal, but please do not let that fool you. It is highly reactive. If you were to throw a chunk of pure sodium into a bucket of water, it would literally explode. Suffice it to say, you certainly wouldn't want it anywhere near your mouth. Now for ingredient 2, chlorine. This is a highly poisonous greenish-yellow gas with a horrific, choking smell. It is incredibly toxic and completely dangerous to all forms of life. So, we've got an explosive metal on one hand and a highly toxic gas on the other. What in the world happens when we force these two terrible things to chemically combine?
Magic happens. That is exactly what happens. Sodium and chlorine combine chemically in a fixed ratio to create sodium chloride, which you probably know way better as table salt. Yes, I'm serious. The delicious, completely harmless white crystals you sprinkle on your French fries are made entirely from an explosive metal and a toxic gas. The properties of the final compound are completely, radically different from the elements that make it up. It is the ultimate bait and switch of chemistry.
And hey, if you think that's just some crazy fluke, let's take a look at the water recipe. We take hydrogen, a gas that is highly combustible and absolutely loves to burn. Then we add oxygen, a gas that acts as a powerful supporter of combustion. So you're mixing two things that are perfectly suited to create a massive, raging fireball. You combine them in an exact 1:8 ratio by mass, and what do you end up with? A liquid that literally extinguishes fire. Water. The chemical bond completely and totally overrides the original properties of the raw ingredients. It's just wild to think about.
Let's bring it all together now in Section 5, elements versus compounds.
Let's quickly summarize the core differences here. An element is the absolute simplest type of pure substance. It's the bottom line. It cannot be broken down into anything simpler, and its smallest unit is an atom. A compound, on the other hand, is built out of those elements. Its smallest unit is a molecule, and its properties are entirely alien compared to the elements it was made from. And crucially, while you can never break down an element, you actually can separate a compound back into its original ingredients, but you can only do it by using chemical methods, like, say, passing an electric current through water to split it right back into hydrogen and oxygen.
And here's the final, mind-bending thought I want to leave you with today. During the formation of any compound, energy is always either absorbed or liberated. Heat, light, electricity, it's a highly dynamic, energetic process. Just take a look around you right now. The plastics, the glass, the fabrics you're wearing, your own breathing body. Every single compound around you required an invisible, energetic chemical reaction just to exist. The universe is a non-stop, infinitely complex cosmic kitchen. So, I urge you to look a little closer at your surroundings today. What incredible, unseen chemical reactions are happening around you at this very second. Thank you so much for exploring the building blocks of reality with me in this explainer. Keep observing and keep learning.